Hello friends, in today's question, three rods of copper, brass and steel are welded together to form a Y-shaped structure. The area of cross section of each rod is 4 cm square. End of copper rod is maintained at 100 degrees centigrade, whereas the ends of brass and steel are kept at 0 degrees centigrade. The lengths of the copper, brass and steel rods are 14, 13 and 12 cm respectively. The rods are thermally insulated from surrounding except at the ends. The thermal conductivities of the copper, brass and steel are 0.92, 0.26 and 0.12 in CGS units respectively. The rate of flow through the copper rod is. So we have three rods. We can draw a approximate figure for that also. And something like this. And we have one end is for, let us suppose this is of a copper. Its temperature is at 100. And this is of a steel. Temperature is 0 degree centigrade, and other end is our brass, and its temperature is also 0 degree centigrade, and let us suppose that this junction temperature is T degree centigrade, and we have to find out the rate of flow of heat through the copper. So in this case we can use the Fourier law, which gives us that the heat transfer through a rod in a steady state condition. We can say from Fourier law the rate of heat transfer if we can represent it as Q by T, then this Q by T can be written as K A delta T divided by L, where K is the thermal conductivity A is the cross-sectional area, delta T is the temperature difference across the rod, temperature difference across the rod, and L is the length of the rod. So at steady state, we can say that the heat flow through the copper is equal to the combined heat flow through the brass as well as steel rod. So you can say the rate flow from the steel plus rate flow from the brass will be equal to the rate flow from the copper rod. So we can write that in steady state, the heat flow through the copper rod is equal to the combined heat flow through brass and steel rods. Through brass and steel rods. So we can write this in the equation form. We can say Q upon T for our copper is equal to Q upon T for brass plus Q upon T for steel. So let us find out the various values or equations for respective terms. So for first is our Q upon T for copper, which can be written as specific heat value of K of copper, thermal conductivity of the copper, which is 0.92, cross-sectional area, one end is at 100, other end is at T, and this gives us, and divided by length of the copper, that is about 46, and this gives us, we can write it as 3.68 100 minus T divided by 46, and yeah, so in this case let me write it in this way. This will be my T minus 100, and here also this is minus, this is plus. And next is our Q upon T for the brass. Q upon T for brass, the temperature difference will be equal to T because other end is at 0 degree centigrade. So we can just put it directly, that will be 0.26 multiplied by 4 multiplied by T and divided by 13. And this will be coming as 1.04 times T 13. And finally we can write for the steel, and this will be giving us 0.12 multiplied by 4, once again it will be T only, and divided by 12. This comes 0.48 T divided by 12. So we substitute all these, let us call this is equation 1. So we can say using equation 1, we get this as 3.68, and we have T minus 100 divided by 46, which will be equal to 1.04 T, and this will be 13 plus 0.48 T divided by 12, and yeah, these are the three equations. Yeah, this is through, and let me revert this back into, because this 100 minus T, because in other end I have written 0 minus T. Okay, so this is basically T minus 0, and this one also is as T minus 0. Okay, so that there is a symmetrical relationship between the equation, and here also this can be written as 100 minus T. So this is now pretty straightforward calculation. So from here we can write that our T will be coming approximately as 40 degree centigrade. And if we check the options that are available, oh sorry, we have to find out the, not the temperature but the heat. Rate of heat transfer. So we simply substitute it in our Q upon T for copper. We get this as 3.68, and we have 100 minus 40 divided by length is given as 46. Yeah, so this will be coming close to as 4.8 calorie per seconds. So we have option number C is the correct option. Option C is correct. So this completes the question. Thank you.